Hello, everyone. This is Monica Muyama. I'm a student at Makerere. I'm doing software engineering year 2. And I'm going to take you through my AI project that solves the problem of ill fit. The contents of my presentation today are going to be the description of the problem that I'm solving, consideration that I took before selecting my data set, then important features in my data set, Bayes theorem, naive Bayes, Bayes networks, then the differences between Bayes theorem and naive Bayes, and then naive Bayes, and the Bayesian networks. So the description of my problem, the problem that I'm trying to solve is ill fit among outfits that are ordered online. Not many people are ordering clothes online, and it's frustrating to order clothes and doesn't fit you perfectly. The fashion designers also nagged doing the same piece again, and it may cost them a lot to refine the piece to fit the client. So when I'm choosing my data set, I put a number of considerations into place. The size of my data set, I try to consider the size to be large in order to avoid bias in case we have a variety of data that you're working with. That means to help us not to be more accurate rather than when you're using little data. Then variety in my data set. My data set majorly has all categories of people, male, female, young, old, so that we can be able, everyone is considered, even when you put in your information, to be able to work for you despite your age, your sex, and your size. Then we also consider the availability of the data set. The data set that I chose is available for research and computational purposes. Then the features in the data set. The important features in my data set are the 3D scans of the figure of the persons. This is then the actual ground measurements of the person selected. They actually select a person and do it ground, they measure everything detail that they want using a tape measure. Then the number and various categories of samples used. As I earlier told you, to avoid bias, we have to take everyone into consideration. So this we're considering both the male and the female, the young and the old. Then the Bayesian theorem. Bayesian theorem is a simple mathematical formula for calculating conditional probabilities. These probabilities are calculated based on hypotheses. Bayes theorem is widely used in machine learning, where it is a simple, effective way to predict classes with precision and accuracy. It states that the conditional probability of an event based on occurrence of another event is equal to the likelihood of the second event given the first event multiplied by the probability of the first event. The formula for Bayes theorem is probability of H given D is equal to probability of D given H multiplied by probability of H out of probability of D, where the probability of H is the prior probability of hypothesis H. Probability of D is the probability of training data D. Probability of D given H, then probability of H given D. Then naive Bayes. Naive Bayes is a simplified version of Bayes theorem, and it's used to classify algorithms as a classification algorithm to classify data into various classes with accuracy and speed. It has a strong assumption that attributes are conditionally independent given the class. While this independence assumption is often violated in practice, naive Bayes nevertheless often delivers competitive classification accuracy. Naive Bayes provides a mechanism for using the information in sample data to estimate posterior probability, that's probability of y given x, of each class y given an object x. Once we have estimates, we can use them for classification or other decision support. Abstractly, naive Bayes is a conditional probability model and problem instance to be classified, represented by a vector x is equal to x, the range between x1 up to xn, representing n features, and this should be independent variables. It assigns to this instance probabilities, whereby we have each of the instance has its own probability for each of the k possible outcomes or the classes of ck. The problem with the above formula is that if the number of features n is large, or if a feature can take on a large number of values, then basing such a model on probability tables is infeasible. The model must therefore be reformulated to make it trackable using Bayes' theorem. The conditional probability can be composed to probability of ck given x is equal to probability of x given ck multiplied by probability of ck out of probability of x. Bayes networks. Bayes networks are a type of probabilistic graphical model that can be used to build models from data and or expert opinion. The graphical model represents a set of variables and their conditional dependencies via a directed acyclic graph. The variables are represented by nodes and conditional dependencies are represented by edges, and these edges are the nodes that are not connected at all. Each variable has two possible values. It's either true or false. Bayes networks can be used for a wide range of tasks, including prediction, anomaly detection, diagnostics, automated insight, reasoning, time series prediction, and decision making under uncertainty. In the differences between Bayes' theorem and naive Bayes, naive Bayes assumes conditional independency, whereas Bayes' theorem will not allow the users to specify which attributes are, in fact, conditionally independent. This means the relationship between all input features are independent. Maybe not a great assumption, but this is why the algorithm is called naive. The deceptively simple algebraic expression of Bayes' theorem enables a lot of development in information processing, channel source, adaptive filter designs, wireless channels, and characterization. The naive Bayes assumption simplifies the math for many distributions, makes some computations involving distributions simpler, especially in classification tasks where getting the exact distribution is less crucial than in estimation tasks. The differences between naive Bayes and Bayes network. A Bayesian network models relationship between feature in a very general way. If you know what these relationships are or have enough data to derive them, then it may be appropriate to use a Bayesian network. Whereas a naive Bayes classifier is a simple model that describes a particular class of Bayesian network, where all features are class conditionally independent. Because of this, there are certain problems that naive Bayes cannot solve. However, its simplicity also makes it easier to apply, and it requires less data to get a good result in many cases. Thank you. That's all I had for you. Don't forget to subscribe, follow, and share my link to all the other friends so that you'll be getting more updates about this fashion project. Bye.